So it's saying how do you start? Well, it's like how do you, what is this one? Projection vectors. Okay. So like if we're trying to get this third one here, we can start here, and we can go v. So v gets us to here, but we really need to get there. So if we go u from here, if we go u, that's kind of u, I guess. So v and then u, we get there. But then we need to get back this way, which maybe I've haven't drawn this to scale. I've not drawn this to scale very well.
Well, isn't the third vector just a dotted one?
Say that again.
Because it says label a third vector. Isn't the third vector just the dotted one?
They want you to say like u plus v,
Oh,
u minus v, u minus 2v, 2u plus v, something like that.
okay.
It's like how do you get this third one from these two? So I was trying to not doing a good job, but you're if you take v and then you come back u, that might be easier to show there. So if you go v minus u, reason it's minus u is it's going the other direction. Then you get this one right here, okay, which is actually going the wrong direction here. Okay, we really want it to go up, not down. So in short, it's you have to flip these. It becomes u minus v. Okay, so maybe that wasn't clear, but let's just take u. So we start with u, okay, and then we go back. Let me snip this in again. Maybe that will help. They didn't choose the sort of the trivial example that would be best to understand this. I think that's why it's harder to explain. So if you start with u, so I'm going to start with u.
Okay.
And then minus v, that means I have to flip that. It means I have to go back the other direction. That's u, that's minus v. There's the dotted one right there. So these match, these dotted ones.
So that's like a projection?
No projections. We're not doing any projections. We're just adding, subtracting vectors. Projections is something else.
So which one is the third vector?
This is the third vector, this dotted one.
Okay.
It's the one that you like. It's like saying go right u, back v, or just go. And usually r is used, or you can just start and go r.
So what they want you to do is draw, like when they say label a third vector, they want you to draw that one, that second one that you drew.
You don't have to. You can draw it to figure it out, but the answer is that it's u minus v is what they're looking. They're looking for this.
Oh.
That's what they want, and the graph is what helps you figure out what they want.
Okay.
Let's try b. Sorry, it's not clear. Let's see why this is difficult to understand. Okay, so like whatever we do, we have to get this thing over here on the right. So if you just do, I don't want to say this, if you just do what's here, if you go u and then you go v, what's the result? That's the result right there. The dotted one.
Is it u plus v?
Yes, and this one should have been done first.
Okay. Okay. I get that one.
Sorry?
I get that one.
Okay. So there's only really four that you probably will see: u plus v, u minus v, minus u plus v, minus u minus v.
And will they always be in the same like configuration?
Well, they can give you anything. I mean, they could tell you u is that one and v is that one. It just depends on what's given.
Okay.
there's so many examples that I can't cover them all
Yeah.
completely, but it is the idea that you're you're going to have to draw on the exam. It's very likely you're going to have to draw some combination of vectors. These are combinations, linear combinations of vectors, and you always add the next one to the this one ends here, so you start there.
So they would give you like minus u plus v, and you would have to draw that.
Sure, but they could give you this picture, but like more common is they just give you two vectors at the origin. Like they say that's u and that's v, and maybe you add them, maybe subtract them. They can also give you the vectors in terms of ordered pairs, like u is 2, 2, v is minus 3 comma 1.
Mm-hmm.
That might be a better way for you to do these problems.
And then what do you do with that?
Well, let's just say that this was, let's go back to A, because A was kind of the uncomfortable one. Let's say that this is the origin. Let's say that u is we got to make the numbers work, but let's say u is like up 2, right 4. Let's say v is down 3. Well, maybe make the numbers work, but down 3, and then right 5. Okay. So now, like, if we were to just add them, or let's do u minus v. So u minus v, because we know that's correct. U minus v is 2 minus a minus 3.
Okay.
So that's 5. And then
4 minus 5.
yeah, minus 1. So that's our that's so the answer is that vector. These numbers aren't right. Down. Oh gosh, that's so silly. I wrote these in completely the wrong order. I'm sorry. Just dealing with some things here. So the first one is I'm sorry. It's 4 right up 2. We'll say that. And the next one is like 5 right down 3.
Okay.
So u minus v would be minus 1, comma 2 minus a minus 3 would be 5. Does that look like this dotted one? Like if you started here at the dotted one, is it left 1 and up 5?
Yeah.
Yeah. So that's another way you could figure it out. Is you could assign values to them.
Okay.
All right. Should we go through 2?
Yeah.
Okay. Find u dot v if u and v are the vectors pictured in the diagram. Okay, so this is a formula. You're finding the dot product. Of these things. So they want you to find u dot v. The problem is that these aren't labeled in xy pairs. Like 3 is whatever it is, and v is whatever it is. So because normally you just multiply this together. Now there's this formula. This is the cosine of theta equals u dot v over magnitude of u magnitude of v. Does that look right in your notes?
Yeah.
Okay, so you can use this formula to find it. This is like a working backwards problem. U dot v is magnitude of u times magnitude of v cosine of the angle between them. So your u is 3, your v is 5, and the cosine of the angle between them is
Pi over 3.
cosine pi over 3.
Okay.
So that ends up being 1/2. So it's.
So you would use your calculator for that, right?
I think your instructor expects you to know this on the unit circle.
Oh, right. That's a
Yeah.
cool thing. Okay.
Now the more challenging way is to actually convert these into XY pairs and then do the dot product that way, which I don't recommend, but that's probably how most students would do it. So like this one on the lower right here, it has an X and a Y value.
Okay.
And it's not, the hypotenuse is 5, but the angle here, if this angle is pi over 3, which is 60 degrees, that means this one is 30 degrees. There's probably a lot too much going on there, but there's 30 degrees angle of 5. So X is 5 cosine 30, and Y is 5 sine 30.
That's I like the other way better.
Yeah. Okay, good, because that's the right way to do it. So now let's look at part B.
Okay.
This one, you'll notice they don't give you the angle. So you might think, well, how can we do it? You're supposed to know the angle. So always keep in mind, if it's not given, you're supposed to know it. If you're supposed to know, it's usually like a nice, well-known value. This angle is 180
Yeah.
degrees. So cosine 180 degrees equals u dot v over magnitude of u, magnitude of v. Cosine of 180 degrees is?
I need my unit circle.
It's the x value on the unit circle. Over here on the left, it's -1.
Okay.
Magnitude of u is 3. So u dot v is equal to -15. So what do you notice about u and v without what's a word you could describe u and v? I mean, they're on the same line, but what else? What about their direction?
Opposite direction.
Opposite direction, yeah. Okay. Now, if the angles, you probably covered this in class, but if the angles, let's just say this is 4 and this is 5. Okay, and it's pi over 2 angle between them. I want you to find the dot product of u dot v.
Good. Okay.
This part up here, yeah. This is the other case you might see on an exam.
Wait, so is that like A kind of?
Yes.
Okay. And for the -1 equals a or u times v 3, that part over there, you just multiplied 3 and 5 and then multiplied that by
Yes.
-1, right?
Exactly. Exactly. Yeah.
Okay, so it's cosine of. What was the equation for the?
Cosine theta equals u dot v over magnitude u, magnitude v.
Is that okay? So then it's cosine. So 4 times 5. Is it 0?
Yes.
Okay.
Okay, so this leads to probably the question you'll get on the exam, is to explain why the dot product is 0 for 90-degree angles and non-zero for not right angles, or how do you use the dot product to determine if the two angles are right angles?
Okay.
Well, if the dot product is 0, if u dot v equals 0, then they're right angles.
Always.
Always, no exceptions. And
Okay.
all right, so the next set of questions is projection question. You actually already know how to do these. You just don't you haven't thought of them this way. So let me just draw something here that goes like this. This has 3, 2. So the projection of this vector onto the x-axis is 3. So there's 3 units on the x-axis, and the projection onto the y-axis is 2 units.
Right. Okay.
Okay, so in this problem over here, like what you're trying to do is you're actually treating B like it's an axis. It's like how much of A falls on B.
Well, how do you know that if they don't give you numbers?
Well, you're just showing it, like it's visually like that amount. This arrow here.
Oh, so that's all I want you to do is just draw
Yes.
that line down.
Yes. Yes.
Oh.
Yes.
Okay.
That's it. But you have to indicate this right angle and a few other
What about
things.
label the projections? What do they?
That is the projection.
Oh, that's just okay. That's what you do.
Yeah, it's like how much of A is on B.
Okay. Not bad. Okay. This one is long, but on the next page on 6.3 major concepts, number 3 has like parts A through F, but
Okay. You would like us to do it?
Yeah.
Through it? Okay, no problem. We'll start with 3A. All right, first thing it says is find the endpoints of the curve. Okay, this is all sort of conceptual. So the curve starts when t equals 2, and x equals f of t, which means that it equals f of 2. Now we have no idea what f of 2 is, but they gave you a hint down below, so we can maybe use that. It says assume that f of t equals t squared, so we can say that this is 2 squared, which is 4, for the purposes of this. And then y is equal to g of t, which is equal to g of 2, and we can just say that that's equal to 2. So there's a lot of work that goes into that for the first endpoint, but essentially if we were to summarize it, at t equals 2, x equals 4, and y equals 2. And then we try this again at the other endpoint, 9.
So then you do x equals.
Yep. X equals f of t, which is f of 9, which is 9 squared, which is 81. And
then just 9.
Yep. Now here's all we know. All we know is that it starts there and ends there. We don't know what it does.
Okay.
We have no idea. Now, because we also made an assumption that that this is t squared and this is t, we don't know what it is. Is that okay for that?
So would you label those like with the parentheses or with the like pointy bracket things?
So that's a good question because it's confusing. Are we doing vectors or not vectors? These are not vectors. These are. Forgive me, I think my screen is frozen. Yeah, this is your 4-2, and this is your 81-9. That's just your ordered pairs.
Okay.
Part B. Consider the parametric curve x equals a plus b plus, and find values of this curve translated to the translation of the original parametric curve. Explain how this curve is affected by the values of a and b. Values of c and d. Okay. So they want to know the starting points. C is the starting point, D is the starting point, and they want to know. So that's a translation of the original parametric curve. Okay. So the idea is that's why they have you do this. So let's just say it's a translation of the original parametric curve. Okay.
Just a lot of words in this.
Yeah. Well, the values of a and b. So all a and b do is they move. This is a vertical, and same with b. It's a vertical transformation because it's outside the function.
Okay.
So that this curve is a translation of the original parametric curve. C and D. Okay. Let's just pick some numbers. Let's say C is 2 and D is 4. So the so X is going to equal A plus F of 2, which we know is A plus 2 squared. which equals 4. Sorry, that part equals, so x equals a plus 4. Is that okay for that?
Yeah, and you just use the points that we found from A.
Well, the part of, yeah, I mean, that's what we're doing. So we're gonna use that. But the thing is it's really asking you to figure out like, well, like what I think it's asking you to figure out, like how you figure out what these values are, C and D, and they're related to this. It's like, this is really unclear, but it's, if you subtract 4 from both sides, a equals x minus 4.
Uh-huh.
Okay, and that means it's a translation of that amount. A is a translation of C, because this is really C. This is really, sorry, x is really a plus f of C.
And then what's D?
So a is equal to x minus f of C. So it's like it's like the translation here is t minus f of C. I don't know. This is really unclear.
I don't think she would ask something like that, honestly.
Let me consult. I probably have this in a book somewhere. So let me just do a quick check if there's anything more useful to help you with on this.
Okay.
Um,
Well, it's like when it says like explain how this curve is affected, it would just be like a vertical shift then.
yeah,
Okay.
but A shifts it vertically. Like wherever it started, A just moves it vertically and B just moves it vertically.
Okay.
Okay, the give a parametric for vertical stretch of the original curve by a factor of 2. So this is just testing. The next parts are just testing. Do you recall how to stretch these things? So the original curve is x equals a plus f of t, or maybe it's just f of t. I'm not really sure. Does it say?
Uh,
Yeah. So the original curve is f of t.
X equals F of T. Yeah.
Yeah. So I'd hate to keep going back to this previous one, but to me it's like c is just a, and d is just man. No, but let's not do that. So if it's just f of t, to stretch it, you just put a 2 in front. Vertical stretch is it's outside.
Okay.
Part D is a horizontal stretch. That is inside the function.
So it'd be like F of T plus 2.
But it's a factor of 5. Now this is where you probably we either it's really, it's like this though. It's f of 1 over k x. This 1 over k has to equal or it's this k ends up being, or this k ends up being the stretch factor. So this 5 goes down here when it's inside a function.
Ooh.
It's a reciprocal.
Okay.
So it would be x equals f 1/5 t, y equals 1/5 g of 1/5 t.
Okay.
And then the last one is reflection.
A negative in front of the F.
Negative in front, exactly.
Okay.
It only affects though the it's not the a, it's just negative f of t.
Right. Okay.
The e, give parametric equations for the inverse relation. This would be t equals f of x.
Wait, how? Because it's just the inverse of x
Yeah.
equals f of t.
Yeah. Although I don't even know if it has one, but then it's it's then also t is also equal to f
So would it be
of y.
g equals y or
I guess this is g.
okay?
This is so far out of because but it could be done.
Okay. Okay, that's fine.
Because it still has to pass the horizontal line test. It has to do a few other things that may or may not happen. So okay, but let's move on to something maybe making me more helpful with.
Number 4 on 6.4.
Okay.
I think this is a more like mathy one, maybe.
Yeah, you're covering several topics that covered are in more detail in Calculus 2 and Calculus 3.
Yeah, she keeps on saying you're gonna need this for calculus.
Maybe if you take it. If you, so uh, so the rectangular coordinates -2, 0. So like you have to figure out like where is that? Where is -2, 0? And that's right there.
Mhm.
So the idea here is like there's two ways you can get to this point. The first is you go up, down, and then followed by left or right. That's what you're used to. That's what rectangular is. You first go up or down 0. I'm sorry. You first go left or right 2, left 2, and then up or down 0. And that's
Okay.
rectangular. I mean that's the essence of that. Polar is you rotate and then you go, or you go and then you rotate. Although it's generally like imagine you're standing here at the origin and you spin and you stop and then you go out 2.
Okay.
All right. So now there's several different ways to get to this place. Now you know that when you're doing your unit circle, you always start here at the origin. So the first way you can get there is to go 180 degrees or pi comma 2. So the pi gets you to rotate so that you're pointing left. Sorry, were you going to say something?
Wouldn't it be -2 because you're going like from the right to the left?
We'll get to that one.
Oh, okay.
Okay, so there's actually 4 answers here. The next one is that's spinning. This is spinning counterclockwise. You can also spin clockwise, and
Okay.
that's -pi comma 2. Because the spin only gets you to like you're still at the origin pointing. The 2 is like taking steps. Like you have to almost imagine you're standing up and then someone spins you, and then you take steps.
Okay.
All right, and then now now you ask, well, can it be -2? Yes, it can be. If I'm just here at the origin pointing right, if I go 0, but then I step backwards 2 times, that's what -2 is.
Wouldn't it be if you're going all the way from like if you're going pi? Wouldn't it be 4 then? Why
You're
is it?
not, because you're not actually on the unit circle. Your unit circle is when you actually do both of these things, because it's like you're right here. If you spin around, you're still here.
Right.
It's not until you take a step that you're moving, or a step that you're moving.
Okay. So then the other one would be
There's
0.
actually 2 more. I didn't realize that. So this actually counts for going both directions. So how do you get back to here? Well, you go 2 pi comma -2, because if you spin all the way around, you're still pointing that to the right, and you take 2 steps back.
Okay.
And then if you go -2 pi, which means you just spin the other way, but you get back the direction you're pointed, but then you take 2 steps back, you get there.
Okay.
It's a really good in-class exercise to do this, to actually spin and step.
All right.
We could do a related one if you'd like, or move on.
Yeah, can we do one more like this?
Yes. Okay, so let's say you're at the position. We'll do one that's not super crazy. Let's say you're at the xy values of 0, comma, -1.
Okay.
So on the unit circle, the 1 unit circle, that means you are right there. So the first way you get there is you start and you go counterclockwise. How many degrees?
180.
0, 90, 180, 270. And we want it in pi, so it's 3 pi over 2. But then you have to take a step. So you're taking a step of length 1.
Wait, is it, so did you go 270 or did you go 180?
Neither. I went 3 pi over 2, which is 270.
Okay, so it is.
Now, how can you get to the same angle but go the other direction, go clockwise?
Wait, I still, okay, so for the 3 pi over 2, so you went, why is it +1?
Because you're always taking a step in the, you're taking a step in the direction that you're facing. You keep thinking you're on the unit circle. There somehow that's been like you think you're here, but when you spin, you're here. You're not there.
But you're still going down.
But it's no longer up and down, left and right. It's you just step in the direction. Everything is, you're either stepping forward or backwards. Like once you spin, your world is a straight line.
Right. Oh, so you don't. Okay.
Like you're here, and your choices are forward or backwards. But before you make that choice, you spin.
Okay. Okay. So any direction you go would be like
Positive.
Positive.
Okay.
Okay.
Yes.
Okay.
But let's say you're facing, well, so, okay, so let's say I want you to still be facing to the right. You can spin this other direction. You can go clockwise, but we think of that as minus pi over 2 degrees. So
where does the pi over 2 come from?
Because this is now minus 90 when you go the other direction.
Oh, because like from 360 to 270, that's minus 90.
Yes.
Okay.
But it's like your body's so like you're spinning your body one way to be pointing this direction, and then or you can spin it the other way and get there.
So why would it not be just negative 3 pi over 2 comma 1 for that one?
Okay, so negative 3 pi over 2 gets you going this. You're here now.
Oh, okay.
You're facing though. You're facing north, and we need you to go south.
Okay.
So we'll get to that one, and you'll start seeing all the relationships. But because, like you just said, if you go negative 3 pi over 2, you now have to step backwards.
Okay.
And if you go just pi over 2, you have to step forwards, or step backwards.
Wait, but I thought if you spin, there's no way for it to be negative because you'd still be facing like.
So once you spin, you only can go forward or backwards. Okay, so like this is where it's if we could just if this was in person, you could stand up and see this. Are you staring at a wall?
Yeah.
Okay, so imagine going 90 degrees. You'll be staring at the wall to your left.
Okay.
Okay, so you go 90 degrees. You're staring at the wall to your left. You can either take a step forward to get to that wall. Okay, which is what we're talking about here. So that's one option. Okay. The other option is you spin to your right so that you're still looking at the wall. You spin to your right now, but you have to spin more to face the same wall you were just facing.
Okay.
And then you'd still take a step forward. That's one option.
Right.
Okay. Now we still want you to face that left. We still want you to eventually face that left wall. So you can spin to the right only 90 degrees. So you're facing the right wall, But then if you take a step backwards, you're there at the wall.
Oh, you're at the left wall.
Yes.
Okay.
And then you can spin, you can still, wherever you're facing the wall, where you're facing, you can spin 270 degrees going left so that you're facing the right wall. And that there's two ways to get there, but then you have to go backwards -1 to be at that left wall again.
Okay, that makes sense.
So the most of the time there's 4 answers. The answers are they're all different angles, but it's how you get there. Clockwise, clockwise, counterclockwise, counterclockwise, and then positive, positive, negative, negative to get to them.
So it'll always be the same, like negative, negative, whatever, just different angles.
Yes. Yes.
Okay. Okay.
Yes. Okay. What can we move on to next?
We can go to number 6 on 9.4.
Okay, the first 2 terms of geometric sequence are 4 and 8. Find the 6th term.
Yeah.
Okay.
I have
I actually don't need a graphing calculator. I don't know why I don't know why they I mean, there's other ones I would think you'd want it for more, but
yeah.
Okay, geometric sequence. The formula for geometric sequence is an equals a1 r to the n-1 power. They're telling you a1 is 4. That's what that means. And a2 is 8. R is the ratio between successive terms. So R in this case would be 8/4, which is 2.
Okay.
So we have enough now to write the formula, because if you want to find a specific term, you always find the formula. Like if this said a to the 8th, we'd want a formula. Now you could just write out more terms. You could say, okay, it's 4, 8, 16, 32, and so on, which is probably faster than the way we were doing it, but I want you to see the formula again. So a sub 6 is, well, let me not do that. An is a1 4, 2 to the n-1 power.
And then
So
you
now,
6.
that's right, a6 equals 4 times 2 to the 6-1 power. So it's 4 times 2 to the 5th. 2 to the 5th is 32. 4 times 32 is 128.
Okay, that's pretty straightforward. So R is just a sub 2 over a sub 1, right?
Or, yeah, or more generally, it's the next one over the previous one. But like in your problem, it was a sub 2 over a sub 1.
Got it. Okay. Plus 1 over 8. Okay. And then you can use that for, like, if they said like find the 90th term, you just plug in.
Yes. Yes. I mean, it's a more difficult problem when they tell you like that it's the first and the third term, or they give you like the 6th term and the 7th, I'm sorry, like 2nd term and the 5th term, like when they're further apart. Then you have to do something else here, but.
Right. Okay. We can go to number 4 on 9.5.
Okay. All right, write sigma k in expanded form. That means to actually write out what you have here. So it's expanded form means like, okay, let's let k equal 1. That's 1. K equals 2. That's 2. K equals 3. That's 3. So this sigma k equals 1 to n k equals 1 plus 2 plus 3 plus, and you have to do enough of these until you figure out the pattern. You're just putting the value for k in here, dot 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 plus n.
So would it just be n plus 1 then? Or
no, we have to figure out what this adds up to.
oh,
Then use a formula for the sum of an arithmetic series to find an explicit formula for the sum. So arithmetic series sum, the sum of the first n terms is n/2 a1 plus an.
Wait, so is what you just wrote above, what you just circled, is that the expanded form?
Yes, this is expanded form.
Okay. So then the arithmetic series. Okay, so
So do you see this form that I wrote down here below? That's like a known one. That's the sum of an arithmetic sequence. That's
okay.
given, known, that there's nothing special there. What they're asking you to do in this problem is to, because this is an arithmetic series, this sigma n k thing, they're saying, what is a1? Well, a1 is 1. What is an? An is the last term, that's n. And they're just asking you to write this, but then maybe distribute in. So it's n over 2 plus n squared over 2.
Okay. So you would write like sigma n2 plus n squared over 2.
You would write this. Yeah, you could write either of these, I think. I think your instructor will take either one. Probably the one on the right, though, would be preferred.
Do you have to write the sigma though, or do you just write the
No,
n?
no, no. This replaces the sigma. Okay, so that's what's not clear. This problem is written to say, to show you that, okay, you can write this in expanded form, but we actually know a formula for this expanded form.
Oh, and that's that, the n2. N
Yes.
over 2 n squared. Okay.
Yes.
Explicit formula? What?
That is an explicit formula. This is an explicit formula for it on the right.
Oh, so this use the formula for arithmetic. That was the n over 2 a1.
Yes.
Okay.
Yes.
Okay. Got
So let's say n was 4. You know that is 1 plus 2 plus 3 plus 4. Okay. That's the expanded form. You could also just use this formula and say, oh, it's 4 over 2 plus 4 squared over 2. 2 plus 16 over 2 is 8. So that's 10. This equals 10. Everything equals each other. They're trying to show you how to shortcut this.
Okay. All right. Makes sense. And then the last one I had was 6. I think we.
6 on the same page?
Yeah.
Okay. Do you have your calculator available?
Yeah, I do.
I just want to have you run through this on your calculator if you don't already know how to do that. You wouldn't get this problem on your calculator, but it's worth at least doing this.
It would be in degree mode, right?
Under what?
Oh no, it would be under sequence, whatever.
Yeah, so it's sum. Sequence was the old way. I think it's like a math, maybe a 0. But you should be able to put in sigma and then x equals 1. And then I'm going to leave that blank for the moment. And yours will be x minus 1. So what I want you to do this is I want you to do it for x equals 10, x equals 20, and maybe x equals 30. So I want you to punch this in your calculator, and then we'll talk about how to do it by hand.
What mode should it be in? It should be in sequence, and then should it be in like degree or radian mode?
None of that matters for this,
Oh.
because you're just multiplying. Oh, that's an interesting question. Summation TI-84.
So I think they told us it had to be in C. I don't know. So then it's
okay. So let me grab some snippets here. This is, I don't know if these are I don't know what it'll do on yours, but here's some snippets. We want to get the sum. But your calculator probably has a sigma. That's something.
Yeah, I have a sigma.
Okay, then that's what you want to use, not this stuff then.
Okay. So then just.
I want you to put 10 in the top, and then 20, and then 30, and tell me the sum each time for this formula.
There we go. Math 0. equals 1, 10, 6, 0.25. I got 0.6 or 0.066 for the first one.
Make sure this is in parentheses. It should be much larger. 1 to 10 on that. So you're putting the 10 up here.
Yeah, I don't think I put it in. I don't think I put the exponent in parentheses. That's what it was. 10 minus 1. Still get the same thing. Maybe I'm in the wrong. Equals 1 times 0.25. And then that is x minus 1. Oh, okay. Now I got 3.84. Is that right? Like times e to the 10th?
No. Okay. So I would work. We're gonna do this by hand, but I would work with your instructor, or there's plenty of YouTube videos on how to do this.
Well, I think the calculator needs to be in sequence mode.
That's usually the case when you're trying to graph stuff. For just calculations like this, generally doesn't matter. But if you were to write out a few terms, if you were to let k equals 1, you would find that the first term is 6, and if k equals 2, the first term is second term 6. 6 times 0.25, which is 1.5, and you would say, oh, I wonder if this is geometric, and you would say, yeah, it is geometric. Now, this r value, if the absolute value of r is less than 1, then it converges. And there's a formula for it. The infinite sum of a geometric series is a1 over 1 minus r. And that's what's happening to get you to see with the calculator, that oh, this must work. So it's 6 over 1 minus 0.25, which ends up being 6 over 3/4, which is 24 over 3, which is 8.
Okay.
All right. So there's so many videos on doing this. I would get caught up on how to do that.
Wait, is it 7.99? Is that
yes.
Right? Okay, I got it.
It's approximately 8. What was the fix? If you don't.
I was putting the n minus 1 like outside of the last parenthesis.
Oh, okay.
You know.
Great.
Okay. Cool.
So you've got a sum here for an infinite geometric series. You got to make sure you know that. Have that on your note sheet.
Okay. That's pretty simple to do by hand then. Okay.
Yeah. All right. I do have to go. I'll send you the notes and the screen recording out shortly, and I'll see you next time.
Okay. Thank you.
Thank you. Bye now.
Bye.